Hello hackers, let's talk about how to choose a database for system or application that you're building. Usually in interviews or if you're given a task on what database to choose to build for your application, you'll often see the databases split up into two different types, SQL and NoSQL types. They each have their own strengths and weaknesses and they both should be considered based on their use case. First, let's define both SQL and NoSQL databases. SQL stands for Structured Query Language. SQL databases are table based, while NoSQL databases can be document, key value, graph, wide column stores. First one is document store. NoSQL databases that store data in flexible schema-less documents commonly use formats like JSON or BSON. MongoDB, CouchDB are some examples of document-oriented databases that store data in flexible JSON-like documents. Next one is the key value store. Key value store data as simple key value pairs, ideal for fast retrieval and storage of unstructured data. Key value store data are Redis, DynamoDB, which are examples that allow you to store and retrieve data based on unique keys. Next one is the graph database. NoSQL database optimized for managing and querying highly interconnected data such as social networks or recommendation systems. Amazon Neptune are examples of graph databases that excel in managing highly interconnected data and performing complex graph queries. Next one is the wide column store. NoSQL databases designed for storing and querying large volumes of data with dynamic schemas suitable for time series or sensor data. Apache Cassandra are examples of wide column stores that are optimized for storing and querying large volumes of data with dynamic schemas such as time series or sensor data. SQL databases are vertically scalable, while NoSQL databases are horizontally scalable. So what does it mean? Horizontal scalability means adding more machines or nodes to a system to handle increased load, like adding more lanes to a highway to accommodate more traffic. Whereas vertical scalability means increasing the power of existing machines, CPU or RAM, to handle increased load, like updating a computer's processor to handle more tasks. Let's talk about the strengths of SQL databases. SQL databases are relational databases, which means that they allow easy querying on relationships between data among multiple tables. Table relationships are really important for effectively organizing and structuring a lot of different data. Secondly, the data in SQL databases is well structured. The room for potential error is therefore reduced. This is because SQL schemas require the data model and format of the data to be known before storing anything. Thirdly, SQL databases are ACID compliant. What does it mean? This means that transactions are atomic, consistent, isolation, and durability. Atomic means transactions are either fully completed or fully aborted, ensuring data integrity. Example, in a banking system, transferring money from one account to another, either the entire transfer operation completes successfully, detecting the money from one account and adding it to other, or none of it happens if an error occurs. Next one is consistent. Transactions maintain the consistency of the database, preserving its defined rules and constraints. Example, in a database where a certain column must have contain unique values, if a transaction attempts to insert a duplicate value, the database will reject the transaction to maintain consistency. Next one is isolated. Transactions are executed independently of each other, preventing interference between concurrent transactions. Example, two users simultaneously updating the same bank account balance, each transaction is isolated from the other, so even if they occur simultaneously, one transaction will not interfere with the other's outcome. Next one is durable. Once a transaction is committed, its changes are permanently saved and cannot be lost, even in the event of system failure. Example, after a successful purchase in an online store, the transaction details are stored in the database. Even if the system crashes immediately after the purchase, the transaction details will still be available and persisted in the database when the system is restored. Now let's talk about the weaknesses of SQL databases. Firstly, structured data might mean fewer errors, but it also means that columns and tables have to be created ahead of time. SQL databases takes longer to set up compared to NoSQL databases. They are also not effective for storing and querying unstructured data where the format is unknown. Secondly, SQL databases are difficult to scale horizontally because of their relation nature. For read-heavy systems, it is straightforward to provision multiple read-only replicas, but for write-heavy systems, usually the only option is to vertically scale the database up, which is generally more expensive than provisioning additional servers. Now let's talk about the benefits of NoSQL databases. NoSQL databases are more flexible and simpler to set up because they do not support table relationships and data is usually stored in documents or key value pairs. They are better choice for storing unstructured data. Secondly, because they are better at handling unstructured data, they can also share this data across different data stores, allowing for distributed databases. This makes horizontal scaling much easier as very large amounts of data can be stored without having to purchase a single expensive server. If you're watching this video right now or like to this video and subscription to the channel would really mean a lot. Now let's talk about the weaknesses of NoSQL databases. Firstly, there's a trade-off between strong database consistency and scalability. Databases are typically designed for distributed use cases and write-heavy systems can be supported by having multiple write shards for the same data partition. This is called peer-to-peer replication. However, the trade-off is a loss of strong consistency. After a write to a shard in a distributed NoSQL cluster, there's a small delay before that update can be propagated to other replicas. During this time, reading from a replica can result in accessing stale data. This weakness of the data eventually being up to date is called eventual consistency. That's it for today's discussion on databases. See you in the next video. Bye.